Okay, well, thank you for the invitation. My name is Zhihua Qu. I'm a professor and the chair of electrical and computer engineering. I wanted to start off by, make sure that, this particular talk is for me to introduce the RISES cluster and its research activity. Given the time constraints, I'm going to basically show you some of the highlights, but more importantly, to show you what are the potential collaborative research opportunities if you have not, been engaging with us. So the title of this is Sustainable and Resilient Energy Systems. And this cluster was established back in 2016 as one of the first 6. Currently, we have about 20 faculty members engaged in the cluster. And we have 9 laboratories that is fully operational. We continue to improve our labs. 8 of the 9 are new labs that we introduced after the cluster. We have, at this present time, $14 million research portfolio. Majority of them, about 65%, come from DoD, and the rest of it come from NSF, utility companies, as well as national labs. This is one of the multidisciplinary university clusters on UCF campus. 3 colleges are involved. One of the features is that we have been leading several large research teams that consist of universities and national labs, as well as industry. So here are some of the members. And again, we have over 20 faculty members engaged at a different capacity, but these are some of the core members, and they have research areas ranging from device level at PV, for example, Chris Davis, all the way up to systems optimizations. We have currently 5 members that are cluster members. They were hired since 2016, and all of them have been very productive. The rest of the faculty members are existing faculty members that joined the cluster from different departments and colleges. So our research really covers from the device level all the way up to the overall energy systems level. Let's see. So what are the motivations behind having the cluster? We started off within the electrical engineering looking at cascaded failures. That's critical for our national economy. We try to avoid and overcome the problems that we have with the aging infrastructure. That becomes a big problem that once a while we'll hear in the news. And our research on power systems really focus upon identify the weak link in the network. And that actually goes beyond the electricity grid. It goes to the overall infrastructure in the cities, in the communities, from transportation all the way up to the broad economy in general. And of course, being here in Florida, we have major vulnerabilities for natural disasters such as hurricane, and we want our infrastructure and grid to be resilient. And finally, but not least, we have a number of cyber intrusions on reliable devices and equipment, and we need to make sure that resilience and security can be achieved with low-cost components. So in order to respond to those major challenges, we're looking at a number of research topics. Here is a list of some of the research topics. Again, individual faculty within the cluster, whom you see their pictures earlier, have a number of lists. So this is not really exhaustive list, but the ideal here is really covering the whole spectrum from renewable energy generation all the way up to storage, utilization, and efficiency and reliability of the energy system. Now with electrical vehicles and new storage technologies on the horizon, we really have a new paradigm in terms of developing, design, and implementing resilient electrical grid, as well as buildings and communities that are associated. So let me just give you an example as what type of research that we do. In the cluster, this is just one example, and I will also give a few current projects to kind of give you a taste. In terms of dealing with natural disasters, and the key is to model the extreme weather events in terms of potential damages to the infrastructure. And that would allow us to develop a resilience design frame to look at vulnerabilities and determine what are the options and have the stochastic based model that analyze the likelihood of impact, and then based upon that, develop defense and recovery schemes. Then, of course, as engineers, we formulate this into mathematical model. We do extensive computational and the physical simulation, and then develop the strategies to address these. And oftentimes, we do case studies for our partners jointly with national labs, and these are how we can make impact. Now, we also have research that working on specific hardwares, such as inverter control, such as PV panels, but all these research are integrated into the overall energy system research that we have. One particular project that we are in the process of finishing is this 100% distributed energy resource study. This is important because if we look into the future, as we're trying to be more sustainable, the reliability, efficiency, and the security of our grid, and everybody involved in terms of customers and communities like UCF campus is critically important. So in this particular study, we're looking at large-scale electrical power systems up to 1 million node. And we're looking at 100% penetration with changes in the weather, and of course, different load profiles. We'll make sure that the system can operate with renewable energy. And we have developed a set of tools. Many of them are now adopted open source tools that allow students and faculty and also industry to use, and that includes such items as state estimation, cooperative control, and situational awareness, and hosting capacity analysis. And so this is really a whole suite of tools that our students and faculty have developed, and in conjunction with our partners, which are listed at the bottom. So this particular project we started in 2017 will be finishing up in the next few months, and we're one of the studies that is at such a scale that utility companies can readily use our results. The other project we're currently working on is long duration storage. We have on campus now a flow battery that is rated at 40 kWh. And we have a hardware in the loop simulator platform that allows us to simulate and test scenarios, not just one device, but how devices will interact with large scale power systems or energy systems with other components, including PV and others. So this is currently a project ongoing with Duke Energy. I want to also share with you that our long-term collaboration with Siemens, this is the autonomous building project that has been going on with a focus on real-time data analytics, optimization, and control. In this particular lab, we have building automation systems in both hardware and software. And we also have real-time displays of data that we received from our partners such as Duke Energy and OUC. We're doing real-time, for example, real-time PV forecasting for OUC that would enable them to optimize their power generation a day ahead. And those are critical improvement in terms of ability of running power system with intermittent renewable energy. I wanted to, instead of looking backwards and tell you a whole laundry list of projects that we're currently working on, I want to share with you the initiatives that we're currently ongoing. These are initiatives that just get started, and hopefully some of you will have interest of participating or collaborating. One of them is called Digital Twin for Smart Campus. This is a continuation of our collaboration with Siemens. Specifically, Siemens Global has approved a project, a pilot, that would allow us to build a digital twin for the downtown campus of UCF. And what this allows us to do is to really study the system of systems, develop data analytics, AI, and intelligent models for our campus, and that will enable us to do real-time optimize the operation, provide the situation awareness, and also do predictive maintenance. Instead of always trying to fix the problem that already caused damage, we want to know when the problem might occur and fix it in advance. The other items that we're working on very actively is cyber-physical system security testbed. And currently we're working with Siemens RocketCon to develop a testbed that would basically fit any industrial control and communication and IoT applications. So there we have 3 layers of security protocols, including wired, wireless communications, satellite, GPS-based communication, precision time protocol over networks, and all the associated, what they call IED devices, intelligent electronic devices that are proliferating. The idea is we can use this platform to test the resilience and security issues of devices that are distributed from certain vendor, and make sure that the system as overall can have the data modalities that we're looking for. And this really leverages the cloud computing capabilities. So we're using basically cyber-physical system properties, the fundamental property of the system, to check the validity of the data and detect intrusions and make corrective decisions. This is one of the 9 labs I mentioned earlier, and we have 2 of those labs are endowed, and the 6 of the other labs are supported. This is one of the examples. So what we try to do in a cluster in terms of the infrastructure is to provide the facilities and the research capabilities that would bring UCF to the forefront of the research competition. And the test bed like this would enable us really to, bring people together to do research and showcase our, accomplishments. And the third one is resilient microgrid testbed. This is the one that we currently envision for the UCF campus. So the idea is, instead of trying to make everything secure, what we do is we have microgrids that individually are secure, and then overall grid would consist of these modular microgrids. that will combine all the resources that we have, including renewables, backup generators, thermal storage. And this is the project that we plan to do with the future funding from DOE. So with that, I'd like to answer any questions you have with regarding to potential collaborations. I would like to refer, if you have a specific technical questions, I'll be happy to introduce you to the members of the cluster so that you can talk to them about the individual research collaboration. Thank you.